This video is about angle bisectors. Our objective is I can apply the definition of angle bisector to different triangle scenarios. All right, so we're going to talk about this thing that's called the angle bisector of a triangle. Let's start with a triangle here. And let's call this triangle ABC. Now, at each vertex, we could have this thing that's called an angle bisector. And what an angle bisector does is it goes from a vertex, and it's a segment that goes to the other side of the triangle, and as it's leaving that vertex, it creates two congruent angles. I'm going to name them angle 1 and angle 2. All right? So let's talk about some things that we know about an angle bisector. The first thing that we know about an angle bisector, if something is an angle bisector, is the measure of angle 1 must equal the measure of angle 2. Now, this works great if you know one of the two angles. Set them equal to each other and then solve. But we also know a second thing to be true. And this second thing is that one of these smaller angles, let's say the measure of angle 1, is going to be half the measure of angle BAC. So in other words, it's half the bigger angle. Conversely, we could also say that the measure of angle BAC would be 2 times the measure of angle 1. Now, wherever I have angle 1 in that statement, I could also put angle 2 in there because angle 1 and angle 2 are congruent or equal in measure. Okay, so what we're going to do is take this concept here and now apply it to different scenarios. All right, so the first scenario, I see that ZP is an angle bisector. I know they give me the measure of angle 1 and they want me to find the measure of angle 2. I know this to be true. I know that the measure of angle 1 has to equal the measure of angle 2 if ZP is an angle bisector. If the measure of angle 1 is 34, then the measure of angle 2 is 34. I prefer to write it like this, though. All right, that's simple. Take a look at this second scenario. I see that UP is an angle bisector. That tells me that angle 1 and angle 2 are congruent. But they give me the big angle, WUV. Well, I know this to be true. I know that the measure of angle 2 is half of the measure of angle WUV. I know that a smaller angle is half the big angle. So then the measure of angle 2 in this scenario would be half of 104. I substituted 104 for the measure of angle WUV, or the measure of angle 2 is equal to 52 degrees. Next scenario. Similar to the first, except now they want to know the big angle, FDE. Well, I know that the measure of angle FDE is equal to 2 times the measure of angle 1. I'm going to substitute 30 in for angle 1, so 2 times 30, or the measure of angle FDE is 60 degrees. All right, this is all true because that blue line in these pictures is what is called an angle bisector. So now let's bring the algebra into this geometry scenario of an angle bisector. All right, in this first scenario, they give me, and it's all based on the given information, they give me angle 1 and angle 2. I look at the picture, I know that the measure of angle 1 has to equal the measure of angle 2. They want me to find x. I'm going to substitute 20x plus 5 for angle 1 and 21x plus 2 for angle 2. I'm going to solve for x by moving 21 over, so I have negative 1x plus 5 is equal to 2. Subtract the 5, negative 1x is equal to negative 3, or x is equal to 3. All right? Scenario number 2 here. Find the measure of or find x, and they give me the measure of angle 1 and the big angle. Well, let's see. I know that the big angle, the measure of angle EGF, is 2 times the measure of angle 1. So the geometry tells me the equation that I can write. I know this scenario has to be true. Now I substitute. 7x minus 4 equals 2 times 4 plus 2x. I substitute the measure of angle EGF and the measure of angle 1. Distribute. 7x minus 4 equals 8 plus 4x. You move the 4x over, so 3x minus 4 equals 8. Add the 4, 3x is equal to 12, and divide by 3, x is equal to 4. All right, the last thing that we have to be able to do is apply the angle bisector scenario, but then we need to find a specific angle. So in this first one, they want us to find the measure of angle 2. I go back to what I know. I know that the big angle is 2 times the measure of angle 2. So the measure of angle SQR is 2 times the measure of angle 2. Why? Because that blue line is an angle bisector. This will allow me to find x by substituting, distributing, and then moving terms around so that I can solve. Subtract 18, so I get x plus 7 is 12. Subtract 12, and I get x is equal to 5. But now that I need to take that one more step, I know that the measure of angle 2 is represented by 9x plus 6. So I have 9 times 5 plus 6, 45 plus 6. The measure of angle 2 is 51 degrees. All right, hopefully you're making the connections between all these steps. Second scenario here. Okay, this one's a little bit unique. They want us to find the measure of the big angle, but they don't give us the big angle at all. All right? Well, let's see what I know. I know, because of that blue line, CP is an angle bisector, so I know this to be true. Measure of angle 1 equals the measure of angle 2. This will allow me to find x. So let's find x first. I have 2x plus 8 is equal to 3x minus 2. Subtract the 3x, negative 1x plus 8 is equal to negative 2. Subtract the 8, negative 1x equals negative 10, or x is equal to 10. All right, so I found x. I do know this is true by something that is called angle addition that we covered a while ago. The measure of angle ECD is equal to the measure of angle 1 plus the measure of angle 2. That's angle addition. All right, so if I take that x and substitute it in for angle 1, or 2x plus 8, I have 2 times 10 plus 8. That's angle 1. Plus angle 2 is 3x minus 2. Substitute the 10 in. I have 3 times 10 minus 2. All right, so this gives me 20 plus 8 plus 30 minus 2. So that'd be measure of angle ECD would be 56 degrees. All right, scenario number 3. They want me to find the measure of angle YWX. That's my big angle. I know, because WP is an angle bisector, I know that the measure of angle YWX is equal to 2 times the measure of angle 2. YWX, angle YWX, is 9x minus 10, and angle 2 is 5x minus 10. Distribute 9x minus 10 equals 10x minus 20. Subtract the 10x, negative 1x minus 10 is equal to negative 20. Add the 10, negative 1x is equal to negative 10, or x is equal to 10. Now I need to find the measure of the bigger angle. The measure of angle YWX is 9x minus 10, so I have 9 times 10 minus 10, or the measure of angle YWX is 80 degrees. All right, hope this helps. Good luck.